Hey there, I'm Ashton Johnston. Today's interactive advanced concept presentation is on gummy bears. I'll start by showing you how I set up this experiment. I'll lower that there. This is everything I used. So I have 2 cups of tap water. There we go. And I have 3 gummy bears. And I have this cup of salt and a spoon. I am going to leave 1 cup of water as is, and then the second one I'm going to saturate with salt. So I will go ahead and do that. This is my salt. So what I'm going to do, I'm going to take the salt in a little at a time, and then I'm going to stir it until it dissolves. And then I'll continue this until there's no more salt that dissolves in the solution. So I'm looking in there, making sure it's dissolving. It looks like this will probably be enough. I see a little bit of granules on the bottom there that are not wanting to dissolve. Okay, that's good. I'll put that over there. We don't need that anymore. Oop, I knocked over Groot. Sorry, Groot. He's my little science partner. So we have a very saturated saltwater solution in this cup, and then a cup of tap water over here. And I'm going to place a gummy bear into each of these solutions. So this is the tap water, and this is the salty water. And then I'm going to let these gummies soak in these cups for about 6 hours, 6 to 10 hours. And I have already done this. So I'm going to bring those over there. And then these are the cups that I did earlier today. So these have been in here for about 6 or 7 hours. This gummy right here is the regular tap water, and then this one is the salt water. I can clearly see by looking at the gummy bears in there at which one is which. Now, let's take a look at this first gummy. This is the one stuck to the bottom a little bit. It's swimming. It's very fragile. I keep breaking off pieces. Okay. There it is. This is the gummy that was soaked in the tap water. It didn't grow as much as I expected it to, but it did deform and like the legs inflated. But height-wise, it doesn't look bigger, just maybe width-wise, it's bigger. I know it was supposed to grow, and it probably would if I left it overnight, but it was also starting to fall apart a little bit. So some of the parts that expanded are at the bottom of the cup. And then this was the saltwater gummy. And in here it is so tiny. This was very concentrated. I put a lot of salt in there. And that's the tiny little saltwater gummy. I think you can see it pretty well. So this is the control gummy. This one wasn't soaking in anything. This gummy is the one that was in the tap water, and this was in the salty solution. Now, why did this happen? Let's start with the gummy bear that was in the tap water. Now, what is a gummy bear made of? It's made of sugar, starch, and gelatin. So when we take the bear into the plain tap water, then it has less water and more gelatin in the bear than outside of it in the solution. That's why the water molecules are drawn into the bear. The water moves to an area that has a lower concentration of water molecules. This would continue to occur, and the bear would continue to get bigger until the water molecule concentration was equal on each side. And because this is, because there's nothing added into the water, the bear may even continue to expand until it burst, is what I would guess. Water molecules are absorbed by the bear through osmosis. The water molecules cross the gelatin, which is like a semi-permeable membrane in the cell, in a regular cell, to equalize the concentration on both sides of the surface of the gummy bear. And by that, I mean inside the gummy bear and the surrounding solution, like equalizing the concentration in both of those. And it'd be great if the concentrations could be equalized by gelatin molecules going through the membrane. That's something I was thinking about. Like, that'd be so much faster if the gelatin molecules could go into the solution. However, it's a semi-permeable membrane, and gelatin molecules can't because the molecules are too big to pass through the semi-permeable membrane. Now let's take a look at the bear in the salt solution. So that was in the pink cup, the little tiny, almost gone bear. I thought it was going to completely disintegrate or disappear when I kept peeking at it throughout the past few hours. The bear has gelatin molecules in it, while the salt water is very concentrated with the sodium chloride molecules and has a low concentration of water molecules. Sorry, excuse my alarm. Has a low concentration of water molecules. When osmosis occurs in this hypertonic solution versus the hypotonic solution, the bear shrinks and it loses water molecules to balance the concentration of water. Well, that's about it. This was a great example of osmosis and diffusion in both hypertonic and hypotonic solutions. I hope you enjoyed this science time with Ashton and Groot. Thank you so much.